Science is alarmed. James Webb has discovered incredible voids. Using NASA's James Webb Space Telescope, scientists recorded unusual phenomena in the center of our galaxy. In February 2025, the giant black hole at the center of the Milky Way put on a kind of light show, reminiscent of a disco ball effect. With the help of James Webb, a group of astrophysicists obtained the most detailed image of the void at the center of our galaxy, where a rotating disk of gas and dust, known as an accretion disk, causes constant flares. These flares do not have a clear periodicity and can occur over short intervals or extend over a long time. Some flares are weak pulses lasting only a few seconds, while others can be truly dazzling and occur daily. In addition, there are a number of weaker changes that continue for several months. We observed a changing pulsating brightness, said Farhad Yousefzadeh from Northwestern University in Illinois, who led the study. And suddenly we see a powerful flare, after which everything quiets down again. We did not find any pattern in this activity. It seems random, and every time we look at it, its behavior is completely new and exciting. These new discoveries can significantly enhance our understanding of how black holes absorb matter from their surroundings, as well as help clarify the dynamics and evolution of our galaxy. To conduct the study and observe the black hole, Yousefzadeh and his colleagues used the NIRCam, which operates in the near-infrared range of the Webb Space Telescope for 48 hours with breaks of 8 to 10 hours throughout the year. This made it possible to track the dynamics of changes in the black hole's activity over time. Although the team expected to record flares, the observations showed that the void exhibits much higher activity than they initially anticipated. The results of the observations showed that the flares occur regularly, differing in brightness and duration. The accretion disk surrounding the black hole produces 5 to 6 bright flares daily, as well as several weaker bursts in between. Although astrophysicists have not yet fully understood the processes occurring near the black hole, Yousefzadeh suggests that the short flares and longer energy outbursts may be the result of two different processes. He believes that the weak flickers are likely caused by minor disturbances in the accretion disk. Turbulent fluctuations in the disk can compress the plasma, which is hot electrically charged gas, leading to a short-term burst of radiation. Yousefzadeh draws parallels with solar flares. It's similar to the process when the sun's magnetic field compresses and then causes a flare, he explained. Of course, the processes around the black hole are much more extreme, as the environment there is incredibly energetic. However, activity on the surface of the sun also has similar manifestations. According to the scientist, more powerful flares. This is the result of periodic magnetic reconnection events, when two magnetic fields collide and release energy, accelerating particles. These particles, moving at speeds close to the speed of light, create bright bursts of radiation. Magnetic reconnection can be compared to a spark of static electricity, which is also a kind of electrical reconnection, added Yusuf. Back. Thanks to the ability of the VP telescopes and IRCam to simultaneously observe two wavelength ranges. And micron. In this study, Yusuf Said and his colleagues were able to examine how the brightness of the flares changes depending on the wavelength. And once again, they encountered an unexpected discovery. It turned out that the brightness of the flares recorded at a shorter wavelength slightly precedes the brightness of the flares at a longer wavelength. This is the first time we've observed a time delay when measuring at these long wavelengths, said Yusuf. Back. We monitored them simultaneously using NIRCam and noticed that the signal at the longer wavelength lags behind the signal at the shorter one by a few seconds, and sometimes up to 40 seconds. This time delay provided additional data about the physical processes around the black hole. One possible explanation is that particles lose energy during flares. This happens faster at shorter wavelengths than at longer ones. This phenomenon is consistent with the theory that particles move along magnetic field lines. To study these processes more deeply, Yousefzadeh and his colleagues plan to use the Webb telescope to observe the black hole for a longer period, preferably for 24 hours straight. This will help reduce noise levels and allow scientists to examine even finer details. When you observe such faint flares, you have to deal with interference, explained Yousefzadeh. If we can observe them for a whole day, it will allow us to reduce noise and see things that were previously inaccessible. This will open up new opportunities for us. We will also be able to understand whether these flares repeat or if they are truly random. A new study conducted by an international team led by scientists from the University of Pennsylvania has confirmed that the bright objects discovered in the early universe do not align with traditional theories about the origin and evolution of galaxies. Using the NIRSPEC instrument of the Webb Space Telescope, researchers identified three mysterious objects that existed approximately 600 to 800 million years after the Big Bang. Spectral data showed the presence of stars that are already hundreds of millions of years old, which is significantly older than expected for such a young universe. To the scientists' even greater surprise, they discovered traces of supermassive black holes in the same regions. These black holes are 100 and even 1,000 times more massive than the supermassive black hole at the center of the Milky Way. The existence of such gigantic black holes and old stars challenges the commonly accepted models of galaxy formation and the growth of supermassive black holes. These massive objects were first discovered in July 2022, when the initial data from Telescope V was published. Later, their existence was officially confirmed. Additional analysis of the spectra obtained with the telescope allowed scientists to accurately determine the distance to these objects. This helped to determine that they are galaxies that existed shortly after the Big Bang, and that they contain both old stellar populations and incredibly massive black holes. This discovery is extremely puzzling. It either requires a revision of our current models of the universe or points to an exotic and rapid formation mechanism in its early era. This is the most unusual and exciting set of objects I have encountered in my entire career, noted study author Joel Leha from the University of Pennsylvania. The infrared instruments of the Webb Space Telescope allow scientists to look back billions of years into the earliest stages of the universe's existence. These objects exhibit characteristics of both supermassive black holes and stars, whose age seems to significantly exceed what was expected for such distant regions. Scientists are not yet able to precisely determine which portion of the radiation comes from each of these sources. It is possible that these are galaxies whose age and mass are much greater than current theories predict. To separate the light coming from gas falling into a black hole from the light emitted by stars. In these distant systems, this is a challenging task. Our current data does not allow us to clearly distinguish these sources, leaving room for many interpretations. Honestly, it's exciting because it opens up a huge potential for new discoveries, shared another scientist from the research team. Moreover, if part of the light indeed belongs to supermassive black holes, then these objects do not fit traditional concepts about the voids. They emit much more energy than we expected, and lack typical signs such as hot dust and intense X-ray radiation. However, what is even more surprising, as the researchers emphasize, is their extraordinary mass. What also raises questions among scientists is how incredible it is. The compact size of these objects, their diameter is only a few hundred light years, which is 1,000 times smaller than the size of the Milky Way. At the same time, the number of stars in these systems is approximately the same as in our galaxy, that is, from 10 billion to 1 trillion. But the volume of these objects is also 1,000 times smaller. If the Milky Way were compressed to the size of these galaxies, the nearest star would be almost within our solar system. The supermassive black hole at the center of the Milky Way, located about 26,000 light-years from Earth, would in that case be only 26 light-years away. And it would appear as a huge bright pillar in the night sky. Scientists plan to continue their research to shed light on these mysterious objects. This will allow scientists to more accurately separate the light coming from stars and the radiation from supermassive black holes. The most interesting thing is that one of the enormous voids was discovered in a completely unexpected way. In 1980, the first astronomer, Robert Kirshner from the University of Michigan, along with colleagues, was engaged in calculating the redshifts of galaxies, that is, determining their speed of moving away from Earth. Considering that the universe is constantly expanding, they noticed a pattern. The farther a galaxy is, the faster it moves. This principle became the basis for creating a three-dimensional model of the universe. While working with the map, which was generated automatically, scientists discovered something unusual. 700 million light-years from Earth, they managed to find a huge empty space in the shape of a sphere. Initially, they wanted to call this place the Great Nothing, but later they gave it a more poetic name. The Void of Bodes. Named after the constellation Bodes, the mythological herdsman who guides his stellar plow along the Earth's North Pole. The diameter of the Eridanus supervoid is 330 million light-years, which is only a fraction of the size of the entire observable universe, 93 billion light-years across. The volume of this gigantic region is about 236,000 cubic megaparsec. This makes it the largest known void in the universe. After the discovery of the Eridanus supervoid, astronomers began to realize the uniqueness of this region. Initially, they found only 8 galaxies within this empty space. However, subsequent observations led to the discovery of 60 galaxies in an area with a diameter of 250 million light-years. As astronomer Greg Aldring noted, if the Milky Way were located at the center of this void, we might have learned about the existence of others galaxies back in the 1960s, 20th century. For comparison, in the vicinity of our Milky Way, there are only about 24 galaxies, and this area of space is only 3 million light-years in diameter, considering that the average distance between galaxies in the universe varies from several million light-years. One might expect that in such a vast void as the Bodes void, with similar density, there would be about 10,000 galaxies. Scientists are eager to understand how such an unusual anomaly in space could have formed. Computer models describing smaller voids, which occur much more frequently, suggest that such regions became empty due to gravitational interactions between galaxies. In the process of their convergence and collision, matter is redistributed, resulting in the formation of empty areas. This process continues to intensify, and the voids gradually increase. However, this is not sufficient to explain the Bodes void. The time since the birth of the universe is too short for gravitational forces to create an empty space of such scale. In response, scientists have proposed a new theory suggesting that supervoids may form as a result of the merging of several smaller voids. Greg Aldring noted that galaxies located within voids take on a shape. The Bodes void may have formed as a result of the merging of smaller voids, similar to how soap bubbles merge into one large bubble. And the galaxies taking on tubular shapes likely represent the traces of the boundaries between these voids. There is also a more radical hypothesis, which has hardly been considered in the scientific literature. In theory, the Bodes void could be the result of the activities of a Type 3 civilization on the Kardashev scale. If such a highly advanced civilization were engaged in colonization, its bubble could expand, obscuring stars and galaxies in its path, enclosing them with a Dyson sphere. This could explain the spherical shape of the void, as well as its extraordinarily smooth boundaries. Considering that the Bodes void is approximately 700 million light-years away from Earth, and intelligent life could have emerged around 4 billion years ago, such an ancient civilization would have had ample time to carry out cosmological engineering on such a scale. Of course, this is nothing more than speculation, but due to the strangeness of the phenomenon itself, such a hypothesis might also have the right to exist. A void in space, especially one as enormous as the Bodes void, provokes a lot of contemplation. Imagine how profoundly the realization of complete isolation would shake someone if they found themselves inside this area, where the distances between galaxies are so vast that space would appear exclusively black and lifeless. This place is not only empty but also represents an almost perfect vacuum, where even the smallest particles, such as dust or rocks, are exceedingly rare. In the void of Bodes, the interaction of particles could occur extremely slowly, perhaps even over epochs, if it's possible at all. This makes the area special, as its low density of matter leads to interesting effects. For example, photons passing through this void could remain unchanged for millions of years, while more massive particles of matter are likely to be attracted to the edges of the void. Thus, this region could become something like a time capsule, where everything remains unchanged over long periods of time. The discovery of such a phenomenon in space has led scientists to reconsider traditional views on the structure of the universe and the process of galaxy formation. This astonishing object confirms that matter in the universe is distributed unevenly, and such voids may provide key answers to many questions about our universe. For further study of such phenomena, astronomers turn to modern 2021. and it became the successor to the famous Hubble telescope. Thanks to its incredible power and precision, the James Webb allows us to explore such distant corners of space that we could only dream of. With each new discovery, this telescope helps scientists gain a deeper understanding of the complex structure of the universe. The main feature of the James Webb Space Telescope is its ability to observe infrared radiation, which cannot be seen by the human eye. Infrared radiation is thermal energy emitted by all objects with a temperature above absolute zero. This opens new horizons for astronomers, allowing them to study objects that are either too cold or are at such distances that their light cannot reach us in the visible part of the spectrum. One of the main advantages of infrared observation is the ability to penetrate through dense clouds of gas and dust that block visibility. This is especially useful when studying nebulae where new stars are born. The telescope can also observe galaxies that have existed since the earliest epochs of the universe, shortly after the Big Bang. Due to the expansion of the universe, the light from these distant objects is stretched, shifting into the red part of the spectrum, beyond the visible range. However, an infrared telescope is capable of capturing this stretched light and give us an idea of what the universe looked like in its early stages. Another important area of James Webb's work is the study of exoplanets. When light from a star passes through a planet's atmosphere, some wavelengths are absorbed by various chemical elements and molecules in the atmosphere. By analyzing these changes, the telescope can determine the composition of an exoplanet's atmosphere and detect signs of substances such as water, oxygen, and other elements that may be associated with the potential for life. To ensure such outstanding sensitivity and resolution, the James Webb Telescope uses several advanced technologies, each specifically designed for its needs. One of the most significant features is its giant mirror, 21 feet and 3 inches in diameter, consisting of 18 hexagonal segments. These segments can move and adjust. They align precisely thanks to a system of motors and sensors, allowing the telescope to effectively collect infrared light from distant objects and direct it to the 4 scientific instruments located behind the mirror. In addition, the telescope is equipped with a thermal shield that protects it from sunlight and heat, providing the necessary conditions for operation. The shield consists of 5 layers of specially designed material that is several times thinner than a human hair. These layers create a shadow for the telescope, reducing its temperature to -387 degrees in Fahrenheit. This is important to prevent the telescope from heating up and to minimize its own infrared radiation, which could interfere with accurate observations. The telescope's arsenal also includes a guidance camera developed by Canadian scientists from the Institute for Research on Exoplanets at the University of Montreal. This camera uses visible and near-infrared light for accurately determining the position and speed of the telescope. It allows for adjustments to the telescope's orbit and direction, ensuring precise navigation in space and confidently locating the necessary objects for research. The James Webb Telescope successfully reached its orbit in January 2022, after which the process of deploying and calibrating all its systems began. In July of the same year, the first images taken by this amazing instrument were presented, which stunned scientists and viewers with their clarity and detail, opening new horizons in the study of space. One of the first images was of a galaxy cluster that formed over 13 billion years ago. This became the deepest and clearest infrared image of the distant universe ever obtained. This image became a valuable source of information about how the process of formation and evolution began. Galaxies in the early universe. Then James Webb captured the Carina and Southern Ring nebulae with unprecedented clarity. These nebulae are clouds of gas and dust ejected by dying stars or serve as a birthplace for new ones. The telescope also took an image of Stephan's Quintet, a group of 5 galaxies located about 300 million light-years from Earth. 4 of these galaxies are in the same plane and interact with each other due to gravity, while the 5th galaxy is in the foreground and does not participate in this interaction. Additionally, the James Webb Telescope conducted the first spectroscopy of the exoplanet WASP-96b, located 1,000 light-years from Earth. Using spectroscopy, the telescope was able to determine the chemical composition of the planet's atmosphere, discovering water as well as signs of clouds and haze. This discovery marked an important step in the search for life beyond our solar system, showcasing the James Webb's ability to study exoplanets and their atmospheres. By utilizing the capabilities of the James Webb Telescope, astronomers can delve deeper into the early universe. This not only helps to reassess our understanding of its age and evolution, but also sheds light on mysteries such as black holes and voids, which remain some of the most challenging puzzles for science.